Okay, I'm going to try to give you a 2-minute introduction to the violin plot. So the violin plot depicts the distribution, uh, numeric distribution of one attribute. In this case, we're doing this in iris data, the sepal petal width, so how wide the width of those are. And we're doing it for different categories. So on x-axis, we have 3 different categories for the 3 different flowers in our species. If you remember, with our irises, we have these 4 different measurements, and we have the species. So we're just doing the sepal width here. And this is really showing that there's a lot of overlap. So what's it's saying is that the versicolor species, their sepal width goes from about 2 to 3.5, and most of them are in the 3 range. But if you saw a flower with a sepal width of 3, it could certainly be this, but it could also be this, and it could also be this. So it could be this. Certainly, if you saw a flower with a sepal width of 4.5, it could only be this one. But again, this isn't probably good. There's a lot of overlap vertically or horizontally here. So this isn't a very good very useful for determining what species a flower is. Now, if we switch this, okay, so I've done it this way here, and I'm plotting the petal length. Here, the petal length, this shows more distinct values. So certainly, if you see something with a small petal length, you know it's this flower. And again, medium petal length more like this, and high petal length more like this, although there is some overlap with these 2 flowers. How do we do this? We say SNS is our library, and then violin plot, and then our X is our species, Y is whatever we're doing, either like the sepal width or petal width. And again, we're looking at our data, one of the column headings here. And then the data is the iris data. Now, you could just as well do this with the cancer data. Here's a SNS violin plot with the cancer data, which we've read in above and cleaned up. And again, diagnosis is our malign or benignant. Here. And so that's what our X, and our Y would be one of the attributes. And again, I've just grabbed the first attribute, radius mean, just to show you as a demonstration here. And so this shows the radius mean. But this shows that while malignant tumors have a higher mean radius, there's still a lot of overlap. So if you saw a cancer tumor, a tumor with a mean radius of like 12 here, you could not tell. It would most likely be benign, but it could easily be cancerous too because there's overlap here. But that's kind of the idea, and you can actually look at some different attributes and see if there are ones that could be used to separate this data better. Okay, that's your introduction.